For the geometric series test, you're going to have functions that look exponential. So our a sub 1 is a number, and that cannot be equal to 0. Now, our r is often also a number when we're just doing plain geometric series tests. Most of the time, our r is our common ratio. And so we have a number raised to a power. A number raised to a power. And whether or not you're starting at n equals 0 or n equals 1 depends on the situation. So for our geometric series test, we know that our series will diverge if the absolute value of r is greater than or equal to 1, and it will converge if it's less than 1. In fact, we know what it'll converge to. The sum of the series will equal the first term divided by the quantity 1 minus r. Now this should make sense to you, because r, if you look, r is the number that you keep multiplying by. Okay, so you'll multiply by it, multiply by it, multiply by it again and again. Well, if that number is more than 1 or equal to 1, what you're saying is what you're multiplying by is more than or equal to 100%. So it should make sense that from term to term, the terms are getting bigger in magnitude. So you're going from 0 to infinity, adding up things that are getting larger and larger in magnitude. It should make sense that that diverges. Whereas if it's less than 1, that's a number or a percentage less than 100%. So let's say it's a 0.5, it's 50%. Well, your terms are getting smaller and smaller and smaller. So in this case, it would mean that the series would converge. The problem some students have is actually recognizing that it's geometric. So you're looking for, in general, a number to a power. Example B is fairly obvious. It's a number to a power. People always ask me, well, where's a sub 1? Well, it's just a 1 sitting right here. It's 1 times. So for this series, to do the geometric series test, you identify your r. My r is 3/2. What I actually care about is the absolute value of my r, and that equals 3/2, which is greater than 1. It's more than 100%. Therefore, this series diverges by the geometric series test. Now it has to be in the exponential form for you to actually do this test. Okay, so this one people get a little bit confused about, but I'm going to rewrite this piece right here. The 3 is just a coefficient. I could actually pull it all the way outside of the sum because that 3 is not being affected by this n. Or I can just pull it to the left and it's acting as an a sub 1. So I could rewrite this as 3 times multiplied by, it's something to the n. Well, if you look, if I have a 2 to the n in the denominator, I'm going to say that's a 2, and if I pull the 3 out, I'm left with a 1. Now 1 to the n is just 1, and my 2 to the n is here, so this is the same exact series as the one above, just rewritten in a different way. So we have 3 times 1/2 to the n. Well, that tells me what my r is. My r is 1/2, my common ratio. So the absolute value of my r equals 1/2. And what's important about that is that it's less than 1. So this series converges by the geometric series test. And if that's all they ask you, you are done. If they ask you for convergence or divergence. If they want the sum, then what you need to do is actually use this formula. You're going to find the very first term, and then you're going to divide by your 1 minus r. So my very first term is, I look down here, n equals 1, so I'll plug a 1 right here. So 1/2 to the first is 1/2 times 3 is 3/2, divided by 1 minus, and my r is 1/2. So 1 minus 1/2 is 1/2, so I have 3/2 divided by 1/2, and there are all different kinds of ways to simplify this or think about it. You can cancel out these 2's that are in the denominator, but if you don't see it, when you divide by a fraction, that means you're multiplying by the reciprocal. That's gone, it's been moved up here. The 2's cancel out, and this equals 3. So this series actually converges to 3. It adds up to 3 if you head out towards infinity.